Ever wonder what it takes to breathe new life into the U.S. Air Force's most powerful jet engines, the ones that roar across our skies and power America's air dominance? Today, we're going inside the secretive, high-tech world where these engineering beasts get rebuilt, tuned, and transformed back to full combat-ready strength. And trust me, you won't believe the precision, sweat, and sheer scale involved. When you think of the U.S. Air Force, images of sleek fighter jets streaking across the sky probably come to mind. But behind every one of those high-speed machines is a story that starts in a hangar, where some of the world's most sophisticated engines get a second chance at life. These aren't your everyday engines you see under a car hood. We're talking about behemoths like the F-110, F-135, and F-119, the heart of fighters like the F-16, F-22, and F-35. Rebuilding one of these is less like routine maintenance and more like performing open-heart surgery on a multi-ton mechanical marvel, where every blade, bearing, and turbine matters. The process begins the moment an engine lands back at a depot or specialized repair facility. Usually after thousands of flight hours, these engines have endured blistering temperatures, supersonic pressures, and environments ranging from the Arctic chill to the scorching desert heat. Every flight leaves microscopic wear, from tiny cracks in turbine blades to subtle warping in metal casings. The first step is inspection, but not the cursory glance you might imagine. This is inspection on a molecular level. Engineers use high-tech scanning tools like ultrasonic testing, X-rays, and laser measurements to detect even the smallest imperfections. One overlooked crack could mean catastrophic failure mid-flight, so the stakes could not be higher. Once the inspections are complete, the real work begins: disassembly. Engines that can weigh thousands of pounds are carefully taken apart piece by piece. Imagine an intricate puzzle where every gear, seal, and fan blade has a very specific orientation and function. Each component is meticulously cleaned using chemical baths, high-pressure water jets, or ultrasonic cleaning machines, stripping away decades of grime, carbon buildup, and heat damage. The parts are then scrutinized again. It's almost like the engine goes through a second birth, a rebirth that blends cutting-edge technology with painstaking manual craftsmanship. Replacement parts are next. But this isn't a simple swap-it-and-go scenario. Many components are custom-engineered to exact tolerances. For instance, turbine blades might be single crystal alloys capable of withstanding over 3,000 degrees Fahrenheit. Even the smallest manufacturing error can throw off performance or, worse, lead to catastrophic failure. Some engines include parts that are literally made to fit the specific engine they're going back into, meaning machinists have to measure, grind, and balance parts by hand to perfection. This level of precision is akin to a watchmaker crafting a Swiss timepiece, except the watch is capable of propelling a fighter jet faster than the speed of sound. Then comes the assembly phase, which is as much art as science. Technicians carefully reassemble the engine, often under magnification, ensuring that every blade, gear, and sensor aligns perfectly. Turbine discs are balanced with micron-level precision to prevent vibration at 20,000 RPM. Sensors are recalibrated to monitor temperatures, pressures, and airflow accurately. Advanced software is loaded and tested to make sure the engine communicates flawlessly with the aircraft's systems. Throughout the assembly, every step is documented and double-checked. Redundancy is the name of the game when human lives and national security are on the line. But even after assembly, the engine isn't ready to hit the skies. It must undergo rigorous testing on specialized stands that simulate flight conditions. Here, engines are fired up to full throttle, reaching temperatures and pressures they'll experience hundreds of times in actual operations. Engineers monitor them for hours, watching for subtle anomalies in vibrations, fuel flow, or exhaust temperatures. If anything seems off, the engine goes back apart, and the issue is traced down to the exact component. This iterative testing ensures that once it leaves the facility, the engine is virtually guaranteed to perform flawlessly under extreme combat conditions. The human element in this process can't be overstated. These rebuilds aren't done by robots alone. They're guided by highly trained engineers, machinists, and inspectors who often have decades of experience. Many of these specialists treat engines with a mix of respect and reverence, knowing that the work they do directly supports pilots and missions that protect the country. They often work in teams, sharing knowledge and maintaining rigorous standards. Because in the Air Force's world, mistakes are not an option. Surprisingly, these rebuild programs are also an economic powerhouse. Each engine can cost tens of millions of dollars to manufacture new, so rebuilding extends the service life of existing engines and saves billions for the military budget. This isn't just cost-cutting, it's strategic efficiency. By keeping a fleet of engines operational and combat-ready, the Air Force ensures that it can respond rapidly to crises anywhere in the world. And the technology developed for these rebuilds often trickles down into commercial aviation, enhancing safety and performance for civilian jets too. Another fascinating aspect is the balance between innovation and legacy engineering. Some of the engines being rebuilt today were originally designed decades ago, yet they remain competitive with modern systems thanks to upgrades in materials, electronics, and fuel efficiency. Engineers constantly integrate new technologies into old frameworks, like swapping outdated control units for digital systems or applying heat-resistant coatings to turbine blades. This mix of old-school engineering know-how and cutting-edge materials science exemplifies the Air Force's commitment to both tradition and innovation. It's also worth noting the environmental and logistical challenges. Handling hazardous materials, managing industrial chemicals, and ensuring engines meet strict environmental standards all add layers of complexity. Plus, these operations are often done in secure facilities with tight access controls, meaning the entire process happens under both safety and security protocols that rival high-tech laboratories. The outcome of all this effort is nothing short of remarkable. When a rebuilt engine is finally reinstalled into a fighter jet, it delivers performance indistinguishable, or sometimes superior, to a brand new engine. Pilots can push their jets to the limit, knowing their engines will respond predictably, reliably, and safely. The roar of a fighter jet taking off with a freshly rebuilt engine is not just noise. It's the sound of engineering excellence, national pride, and operational readiness all coming together. Finally, what makes these rebuilds truly compelling isn't just the technical mastery. It's the story of human dedication, precision, and ingenuity that goes unseen by most of us. Every flight, every mission, every maneuver in the sky relies on the invisible work done in these hangars. The next time you watch an F-35 streak across the horizon, remember that the engine powering that jet has likely been taken apart, inspected, rebuilt, tested, and perfected by a team of engineers who treat it like the crown jewel of American aerospace. The process is a perfect blend of science, craftsmanship, and patriotism, demonstrating how the Air Force sustains its edge in an era where every advantage counts. Rebuilding the Air Force's biggest jet engines isn't just maintenance. It's a high-stakes, high-tech rebirth that keeps America's skies secure and our pilots flying with confidence. The combination of precision engineering, cutting-edge technology, and dedicated human skill is nothing short of awe-inspiring. If you enjoyed this deep dive into the world of Air Force engine rebuilds, hit that subscribe button and turn on notifications. Join us for more behind-the-scenes stories of American innovation and strength, and get an insider look at the machines that defend our nation every day.